All right, Mr. Ahmed here for 7.2. Goal for today is to work with parallelograms. First off, defining a parallelogram. A parallelogram is a quadrilateral, so it has four sides with two pairs of parallel sides. So, for us to identify a parallelogram, we have to kind of look at the diagram. If we see that the opposite sides are parallel, one pair, two pairs, we know that the figure is a parallelogram. Parallelograms have a ton of special characteristics, and we're going to go over those today. So the first one is if the quadrilateral is a parallelogram, then we know that its opposite sides are congruent. So if parallelogram, going to kind of draw this like this. Two pairs of parallel sides. Then the opposite sides are congruent. Okay. In a similar manner, if the figure is a parallelogram, then we know that the opposite angles are congruent. So the opposite angles would be the same measure. Okay, so that's our first two characteristics of parallelograms. Opposite sides congruent and opposite angles congruent. As we work through this chapter, we are going to work with numerous figures that have tons of special properties. The next one, if the quadrilateral is a parallelogram. So if we have a parallelogram, then the consecutive angles are supplementary. So that means they have to add up to 180 degrees. So as I kind of take a look at this, we already know that the opposite angles are congruent. Hence, they're both x. Both y. All right. These two have to add up to 180. These two add up to 180. These two add up to 180. And these two add up to 180 degrees. And it goes along with the theorem we were working with in chapter 3, the consecutive interior angles between parallel lines, because these lines are parallel, these are consecutive interior. So they are supplementary. So, working through some problems now. As I take a look at the diagram, we're supposed to find x and y. First thing I notice is it's a parallelogram. The opposite sides are parallel. So that means that the opposite sides are congruent. So 13 has to equal x plus 6. And then we can solve. X is equal to 7. Now for the y, opposite angles of a parallelogram are congruent. So y is equal to 68. Okay. The next one, again, we have another parallelogram here. Opposite sides are marked. So we're supposed to find x, y, and z. I think I'm going to start with y. Y is pretty easy. Opposite angles are congruent. So that means y has to be 123. So I found 1. Opposite sides are congruent, so we'll set up an equation to find x. Okay, 37 has to equal 2x minus 3. And we'll solve. So we'll add our 3, 40 equals 2x, and x is equal to 20. So we found two of the values. We have one left, and that is z. Now for these two, these are consecutive interior angles. So for us to find z, z plus 123 has to equal 180. These two have to add up to 180 because they're consecutive interior. So for us to solve, we'll subtract our 123, and we get 57. And we got it. Okay. One more example here before we work at the diagonals. Again, we're looking for x and y. The figure is a parallelogram, so all the properties are going to be true. The opposite sides are congruent. So 18 is equal to y plus 3, and y is equal to 15. Opposite angles are also congruent. So 2x is equal to 50. X would equal 25. All right. Next, we're going to look at the diagonals. All right. The diagonals of the parallelogram go from one vertice over to the opposite one. Okay. They bisect each other. So if the figure is a parallelogram, again, I'm drawing it out. Opposite sides parallel. Then I know that these diagonals bisect each other. So that does not mean all four of these parts are congruent. PM could be, let's just say 5. That means MR is 5. This piece, however, is not necessarily also 5. It might be something along the lines of 3 and 3. Okay, that is a possibility there. And then we would just know that not all of them are the same size, okay? So as I look at the next diagram here, find the value of x and y in each parallelogram. So the problem told me it's a parallelogram instead of it being marked. So since it's a parallelogram, the diagonals bisect each other. So x is equal to 9 and y is equal to 8. So they're not all the same size in a parallelogram. Again, diagonals bisect, so 12 is equal to x plus 3, so x is equal to 9. And 2y minus 1 is equal to 9. 2y equals 10, y is equal to 5. Okay, working with the diagonals. And finally, putting it all together, we got a big problem here this time. So find all the indicated measures. So the first thing, I'm just kind of going to look at this thing. I could do it in any order that I really want. We'll start at the top. NM goes from here to here. The diagonals bisect each other, so NM is 2. KM, let's see, where's KM at? KM is the whole thing. 2 plus 2 is 4. JM, all right. We're going to come back to that here in a bit. Let's see where we're at. JM, KL, opposite sides. So they are 9.5. JK, opposite sides congruent. So JK is 11. All right. Now, one thing I do want to mention here, if you see something like this where it has a little parallelogram drawn next to it, that indicates it's a parallelogram. This is the symbol for parallelogram. I kind of skipped over that in the instructions. I just knew that, got excited. All right, back to the problem. Angles now, JML. So I got to find JML. JML. So this part's a little bit tougher. I have this 110 here, and the 110 is indicating this whole arc. That's why that's drawn in. So this entire angle is 110. So that means this entire angle here is 70 degrees. So the missing part is 40. Okay, the reason why it's 70 is these are consecutive interiors, so they have to add up to 180. All right, so I would just took 180 minus 110, knew the whole thing's 70, then I could find our 40 for JML. Oh, I actually found a different one. JML is the whole thing. That was 70. And KML is our 40. So make sure you trace those pretty closely. Last one's KLM. So that's the big one here up on the top. Opposite angles congruent, so that's 110 degrees. So lots of things going on in there. One thing I think I might do is just trace over these just so it's a little bit easier to see them. So angle JML was this guy here, the whole thing. So like I was talking about, when I found that, these are consecutive interior, so I took 180 minus 110 to get our 70. KML was the little part, that was our 40, because these two had to add up to the whole thing. And KLM was the big one up at the top. I'll highlight that one in yellow. So that one's a little easier to see. Opposite angles were congruent, so this whole thing up at the top was 110. All right, that's it for today. Have a good one.